Um, Good morning and namaste to everyone. I wish you all are in good health. On behalf of Nepal Engineering Association and the Asian Civil Engineering Coordinating Council, I, Purnima Acharya, would like to welcome you all to this webinar on Now or Never Beholding Sustainability in Civil Engineering, which is a second international webinar organized by the Asian Civil Engineering Coordinating Council, ACECC, every month. Today's webinar is organized in collaboration with Nepal Engineers Association, NEA. We are thankful for the opportunity to host this second webinar from Nepal. The first webinar was hosted by Indonesia in May, and the third one will be hosted by Philippines in July. As we are aware, Nepal, like rest of the country, is battling the global pandemic with devastating consequences, especially to the vulnerable communities at large. The emergence of COVID-19 has highlighted and fortified the concept that when we destroy the biodiversity, we destroy the system that sustains human life. Therefore, the relevance of sustainability and its role in future planning has never been so important. As we mark this day as a World Environment Day, it is a wonderful coincidence to be able to host this webinar, and we firmly believe that the context will definitely elevate the session, along with the invaluable content from our three distinguished speakers. So, with no further ado, I would like to introduce Engineer Suraj Gautam, Vice Chairperson of AECC Future Leader Committee, who will be moderating today's webinar. I sincerely hope this session will be of great help to all the participants. Thank you all for the support we received during this event, making this event possible. Thank you everyone for your presence. Over to you, Suraji.
Thank you so much, Purnimaji, for beautifully setting up the stage for today. Hello, everyone. Namaskar, greetings, and very good morning from Nepal. It's plus 5:45 GMT, and this is me, Suraj Gautam, professionally a civil engineer and with a specialization in disaster risk management. And I'm currently working as a deputy chair for this ACECC Future Leaders Committee. And ACCC has been regularly organizing this international webinar series, and it is my pleasure to welcome you all in its second episode. This episode on Now or Never, Beholding Sustainability in Civil Engineering is hosted by AKIC FLC in coordination with Nepal Engineers Association and technical support by Institute of Himalayan Risk Reduction. So on behalf of the organizing team, we are very grateful to our distinguished guest, eminent speakers, and all the participants from different corners of the globe. So I am very much pleased to share you that we have had like more than we have had an overwhelming response to this webinar. More than 800 participants from 17 countries have already registered for this webinar, despite this difficult, despite this different time zone barrier and despite this COVID-19 pandemic situation. So to address this request, we are going live on our technical partner social media, and we believe this webinar will set up an amazing platform for strong international collaboration among youth civil engineers in our region. So before we move on to our presentation, I would like to uh, welcome you all once again, and this is the program schedule for today. So AKIC has been the Asian Civil Engineering Coordinating Council, which was established on September 27, 1999 in Tokyo to promote collaborative works towards the sustainable development of infrastructure within the Asian region. And a group of AKIC Future Leader Committee is a group of young leaders below 35 from across South Asia Pacific with representatives from 14 member economies. And we are looking to create a sustainable future leader forum and also promoting a diverse and inclusive culture for young civil engineers and also creating avenues for the professional development and strong international technical collaboration among the civil engineers in AKIC member countries. So before we move on to the presentation, I would now like to request our honorable guest, Professor Dr. Triratna Bajracharya, President of Nepal Engineers Association and former Dean of Institute of Engineering, Tribhuvan University, to share his valuable remarks.
Thank you very much, Suraj sir. Respected speakers, I can also see Dr. Sohail Basir, the organizers, ladies and gentlemen. Namaste and hello to everyone. I'm immensely pleased to be a guest of today's webinar, which is one of the international seminar series organized by the Future Leaders Committee. The Future Leaders Committee is recently formed by the 40th Asian Civil Engineering Coordinating Council, ASIC, Executive Committee held on March 26, 2021. Nepal Engineers Association is one of the members among 15 different engineering organizations worldwide of ASEC. The Asian Civil Engineering Coordinating Council Future Leaders Forum is a platform of youths aged below 35 years across the Asia Pacific with representatives from 14 member economies.
Triratna sir, are you there? I think we have some technical issues over there. Triratna sir, are you there?
I think he lost the connection.
I think he's rejoining. Triratna sir? Okay, let me share. We are organizing this webinar in collaboration with Nepal Engineers Association. Nepal Engineers Association is an independent non-profit organization which represents more than 36,359 engineers in Nepal. And we have been working closely with the engineers in the country, and NEA mandates including promoting the fellowship, goodwill, and cooperation assistance among the Nepalese engineers, safeguarding their rights and interests, and promoting the development of science and technology. For this webinar, we have technical support from the Institute of Himalayan Risk Reduction, which is an organization working especially in the sector of disaster risk reduction and promoting science-based decision-making in disaster risk reduction and management. Triratna sir, are you there? Okay, so meanwhile, AKIC FLC is hosting an international webinar series, rightly mentioned by Purnimaji as well. So we have had the first webinar episode on May 1st, and then we are here today. So we'll be shortly starting our presentation. And for this, we have eminent speakers, and we have Dr. Chhatra Bahadur Basnet, who is a professionally a rock and tunnel engineer and working as CEO at Clean Energy Consultant Private Limited. Similarly, we have engineer Amrita Gautam, who is a project lead at Drink Pani Nepal project and also a doctoral candidate at Technical University of Cologne, Germany. And also we have engineer Dipendra Gautam, who is Chief Executive Officer at Interdisciplinary Research Institute for Sustainability. So without any delay, I would now like to move on to our webinar session. There are some in-house rules for this webinar today. The entire session of the webinar is being recorded and will be available on our YouTube channel. The webinar will be around an hour, consisting of 3 different 15 minutes presentation, followed by 10 minutes of Q&A session. And all the participants will be muted. And if you have any queries regarding, during the presentation, please feel free to write to us in our chat box. You can do it by introducing yourself and writing the questions to whom you would like to address. So we'll be sharing the feedback form at the end of the presentation, and we'll be providing participation certificates to the respondent. So now, without much further delay, let me introduce our first speaker for today. We have Dr. Chhatra Bahadur Basnet, who is a rock and tunneling rock engineering expert working as a CEO at Clean Energy Consultant Private Limited. He has completed his PhD degree in rock engineering in 2018 and MSc in hydropower development in 2013 from Norwegian University of Science and Technology. He has over 13 years of experience in research, design, and implementation of hydropower projects in the Himalayan geological conditions. He is the author of a number of scientific papers published in the internationally recognized journal and conference proceedings. So with this, I would like to now request Dr. Chhatra Bahadur Bosnet to.
Excuse me, Suraj. So my internet was interrupted.
Sorry.
So I have not completed my best wishes.
Yes, sir. Please.
Shall I continue?
Yes, sir. Please.
Okay. So I am pleased to inform you that they both have been nominated for the Executive Committee of Future Leaders Committee, Engineer Suraj Gautam for the Deputy Chair and Engineer Purnima Acharya for Executive Member. Even in this COVID-19 pandemic, the Future Leaders Committee managed to organize this second series of international webinars on the topic, Now or Never, Beholding Sustainability in Civil Engineering. Three personalities figures, Dr. Chandrabahadur Bosnet from Kathmandu, Engineer Amrita Gautam from Cologne, Germany, and Engineer Dipendra Gautam are going to present their papers. I am confident that the knowledge, ideas, and best experiences shared by the speakers will be very much useful. I, on behalf of the Nepal Engineers Association, would like to congratulate the Asian Civil Engineering Coordination Council Futures Leader Committee for organizing this webinar and would like to wish all the best for future endeavors. As we all know, the government of Nepal has started embarking upon major projects such as highways, railways, tunneling structures, hydropower projects, water supply projects, and international airports in the country. No doubt, this would boost the overall growth of the power sector, connectivity, employment, construction, and resulting in several spin-offs. We would also like to express our commitment of support with the ASEC FLC in its every endeavors for the advancement of engineering profession. Once again, I would like to express my gratitude to the organizer for inviting me to this event. Thank you very much.
Thank you so much, Professor Dr. Triratna sir, for the wonderful remarks. And we're really honored to have your presence in this webinar, and we look forward to working with the team. And and we are extremely sorry for the technical glitches which we had. So without any further delay, I would now like to request Dr. Chhatra Bahadur Bosnet to provide his insights. So the floor is open, sir.
Thank you, Surajji and ACECC and any Nepal Engineers Association for giving me the chance to present some of my experience in the design of underground openings in hydropower projects. If something technical happens, then please just let me know. Okay. Now I will start my presentation. My topic is design of large underground openings in hydropower projects. And I'm from Nepal, of course, and I'm working as Chief Executive Officer in Clean Energy Consultant Private Limited. Okay, before going to the underground openings, let's understand a bit about what are the components in hydropower projects and where these underground openings are located. So in hydropower projects, we use water and vertical height difference to generate the electricity. For that, we make the dam, we construct the dam, and the water will be drawn from the intake, and tunnel will carry the water up to the powerhouse. And from the powerhouse, tunnel again will discharge the water back to the river. So this is the basic layout of the project. Now let's understand more about how it looks in the while we make the sections along the alignment. Then water from the upper reservoir or upper reach from the river, it will be carried by the headdress tunnel. And then there is some arrangement in between, pressure shaft, or we can also make inclined tunnel. And we will have a steel lining in front of the powerhouse, and we will have a tail race in the end to discharge water back to the river. So you utilizing the water discharge and the height difference between these two levels, we generate the electricity. So nowadays, at the present condition in Nepal, the hydropower industry is booming. So there are a lot of scope of those underground openings while we we deal with the large amount of water. Let's go further. What are the tunnels there and the caverns which we make in hydropower projects? Diversion tunnels during the construction, address tunnels, source tunnels, and penstock tunnels to carry out the water from head water system to the powerhouse. And there is powerhouse complex and tailless tunnels. And today I'm going to focus on the powerhouse complex and other caverns because they are the bigger openings that we make in the hydropower projects. So how we design those caverns? What to be designed? The shape, the size of the cavern, the orientation of the length axis of the cavern, and the spacing between the caverns. If we have more than one caverns, then we need to space them so that the activities that we do in one cavern that doesn't affect to the other caverns. So for that, what is the design process then? First, we need to have the input parameters. For example, joint data, attitude and other parameters, and rock mass quality. There are many rock mass classification that we find around the world. So we can use one of those to quantify the rock mass quality and rock mass properties. For example, the strength and deformability properties, in situ stresses, that means the loading that comes to the opening, and the geometry, of course. It also matters the design of the caverns. And what are the approaches that we can use? We can use analytical solutions, empirical approach. For example, kinematic analysis. If we have the jointed rock mass, then we need to use kinematic analysis for the support design and the numerical models. Then what would be the outcome is analysis result. But the important part is recommended rock supports, that the interest of the investor, of the engineers at the end. So we produce the report to formalize all these results and recommended rock supports. Okay, let's look at where these caverns are located. There is powerhouse cavern, the main cavern in the hydropower projects, which is connected to the shaft, which is connected to the penstock tunnels. And then we'll have transformer caverns to put the transformer inside the caverns, which are near to the powerhouse. And there could be other caverns, for example, gate operating chamber and downstream salt chamber. It depends on, these are mostly depend on project specific, these are more project specific components. So while placing the caverns, then first we have to know what is the spacing that we can provide between the caverns. If you look at the figure here, there is a big cavern, powerhouse cavern, and there are other smaller caverns. So we put a certain distance between these two caverns and also those two caverns. So we have to understand how we space these caverns based on the rock mass condition, based on the stress situation, and based on the strength of the rock. So that's really important. For example, where these caverns are located, it's very important because the topography basically determines what would be the problem that comes inside the tunnel, inside the caverns. So this is basically a mountain that we usually find in the Himalayan region. So there could be multiple rivers coming. That makes the topography quite complex. And in the right figure, we can see the caverns that is already excavated inside this mountain. So we have to find what are the problems that may arise in the caverns inside while designing the cavern. So for that, we need to have the geology of the area. For example, we have jointing information, the rock types here, it's calcareous gneiss, and other information, the superficial information like column deposits and alluvium deposits, and the thickness of those deposits and strength on the other quality of the rock. We have to know that before going for the design. And also we need to have the jointing information because the bigger caverns, we usually make them in the relatively better rock mass. So in the relative better rock mass, there will be jointing that determines the failure criteria of the cavern. So while orienting the length axis of the cavern, we have to look at the joint data, and we have to find the different favorable orientation of the tunnels. For example, in this figure, the red one is most favorable because it bisects the angle between two joints, and this dashed line also is favorable. But due to the construction easiness and other requirements, we may have to orient the tunnel in other directions as well. Then we have to find the way how we minimize the jointing problems in the caverns. Just like this, the right figure is the 3D representation of the joints, which is quite important to understand how the wedges will be formed inside the cavern. Then we use the support chart. For example, Q chart. It's a very popular chart we can use to design the cavern, which is developed by Barton et al. 1974. Here we need to have the height of the cavern, width of the cavern, and also the excavation support ratio, which depends on the type of the excavation, type of the opening that we are going to excavate. Then once we know the equivalent dimension, then we will find the support based on Q value, which is calculated by those parameters which are mapped at the field. So I'm not going into detail of this chart. I'm here just to show how it looks and how we use in the support design. Then we can use on-wedge analysis, the kinematic analysis based on the joint information. Here in this particular example, we have 3 joint sets, and we have representative joint orientations and other informations, other parameters of the joint. Then we use the model to find how big the wedges will be formed and if these wedges are critical or not. Then once we find the weight and factor of safety, then if the joints wedges are critical, then we will apply the support. For example, the rock bolts or cable bolts based on the weight of the wedge and the orientation of the wedge that going to fall down. Let's go further. After we do the preliminary support design from Q chart or the similar, and after we do the kinematic analysis, we can move forward to the finite element analysis. So for that, we need to have the rock mass parameters. For example, we need to have rock type, compressive strength, Young's modulus, Poisson's ratio, and other parameters. For example, geological strength index, material constant, and disturbance factor. Then we have to find a way which model we are going to use. For example, if we are going to use 2D model, then we have to make some assumptions that the model will depend on that it's whether it is plane strain or not. If the condition is for the plane stress or plane strain, then we can use the 2D model as well. Then another important parameter is the in situ stresses. For example, in the Himalaya, we have very limited stress measurement data. Therefore, we can use the world stress map to determine the orientation of the stress. But for the magnitude of the stress, we don't have information from world stress map, so we have to measure the stress and apply the relevant theory of stresses. So in that particular case, we have assumed variation of K. K is the stress ratio, and it will be reduced with the depth. So if we have to know where we have structures located. For example, in this particular case, it's between 300 to 400 meters from the surface.
So we have 2 minutes.
Okay. Then we have to resolve the stresses to the required directions in plane and out of plane in 2D models. Then we use a valley model to find the stress at the location of cavern. But since this is very big model, then compared to this size of model, our opening is very small. So we need to find a way to make the constant state model, applying the smaller size of the model. For example, here it's about 200 by 200 meter. Then we apply the stress from the valley model to the constant stress model. Then we need to have the support parameters before going for the support design. Of course, I'm not going into detail of those parameters. Just to know, we need the support parameters. And since these structures are really big, so we cannot excavate these structures at once. So we have to find different stages, and we have to optimize which stage has to excavate first and which is successfully excavated. Then we have to apply the support at the stages. Once we excavate the one stage, then we have to apply the support, and vice versa. And then we have stress results from the model, and we can also see if the supports are failed or not. If they are failed, then we have to increase the support capacity. If they are not, then we have to find the optimum capacity of the optimum support requirements. Then, for example, we have to also control the deformation, because after we excavate the caverns, we have to make the pillars, and for example, in this particular case, we have to make crane beam. So we don't allow any deformation in the crane beam. So we have to control the deformation as well with the support. And finally, in the complex geometry, we have to use 3D models, which is quite complex. And these models we only use at the latter stage of the design, because in the preliminary stage, we have limited resources, limited input data. So starting from the empirical approach, we can use at the next level, we can use a 2D model, and in the end, we can use 3D model before going for the construction. So this is the final recommended support I am showing here, just an example where we have rock supports and the steel fiber reinforced circuit. Finally, what are the challenges that we usually find in the Himalaya, basically, while designing the caverns? Rock type and quality, generally highly fractured, schistose, presence of microfault, faults, shear zones. That makes us very difficult to design and to excavate the caverns. Quantification of rock mass parameters. Usually we have lack of testing laboratories that usually gives us the required quality of data. Quantification of stress data, as I already mentioned in my previous slides, it's very limited, and which is very important parameter, and which is quite expensive to do for each and every point or each and every project. So we have to make certain assumptions. Potential stability problems. Rock burst and squeezing is very frequent, so that makes us difficult while excavating the caverns. And construction experience is very important, which is very limited. Nowadays, it's being increased. This issue is the caverns and the tunnels are very important in case of Himalaya for its development. Thank you very much for your kind attention.
Thank you. Thank you so much, Dr. Chhatrabahadur Basnet. It was indeed a very technical session, and definitely we have some insights regarding the design of large underground openings in hydropower projects. So it was really interesting to explore some dimensions on the caverns, and we hope we'll be having some more interesting questions regarding this in our Q&A session. So for now, I would like to now move on to our second presentation, and for this we have Mr. Deependra Gautam. He fundamentally researches in structural earthquake engineering together with multi-hazard vulnerability of structures. He is also serving as the CEO of one of the most prolific research institutes in Nepal, IRIS. He has published more than 5 dozen research papers and book chapters in top-tier international journals and edited volumes. His recognitions include Young Scientist Award 2019 by the Government of Nepal, Outstanding Youth Professional Award 2019 by Nepal Engineers Association, Dr. Harka Gurung Memorial Ramakrishna Sirjana Young Scientist Prize, Braja Das Award, Excellent Young Researcher 2015, and others. He aims to accelerate multi-hazard resilience in developing world structures. So the floor is all yours, Mr. Dipendra Gautam.
Can you please just unshare your screen? Thank you. Thank you, Suraj. My name is Dipendra Gautam, and currently I'm Chief Executive Officer of IRIS. You can see over there. So I have also provided my website here. So further information can be grabbed from that website. So a very good morning from Nepal. I hope you are in different parts of the world and hope you are enjoying it. And today I'm really going to talk about beyond the threshold of multi-hazards, resilience lies. This is a little bit rhetorical, but still I'm going to focus some of our researches that we have been conducting over this period, let's say over this half decade in Nepal. And then I'm really going to share some of insights from our recent researches, publications, and some insights from real-time observations in Nepal. So let's go to my presentation. So I'm really going to start with the saga of multi-hazards. So the story of multi-hazards was really introduced after 2010 in Nepal. And I hope all the Asian countries that are facing the similar situation. But we really got a chance to work in one of the egregious multi-hazard scenario in central Nepal after the 2017 flash flood. So we try to pertain some of the damage mechanisms, and we also try to pertain some of the losses over there. So you can see the red dots over there. So the red dots were the buildings. They were damaged by the same earthquake, right? So they had the similar level of damage. But after that, there was a flash flood, and that flash flood really made it really some insightful remark on our structures, especially the rural vernacular stone masonry buildings. And you can see that the damage has increased by at least 300%. So similarly, you can relate with losses there. So what happens in especially Asia and other developing world is that if you have particular natural hazard and then you have some damage in your structures and infrastructures, to be precise, like the buildings and bridges or other stuff. So if you have some structures that are already damaged, but it is very less likely to have rehabilitation strategies deployed over the time. So if your rehabilitation strategies is not really deployed, then surely the next natural hazard will really increase the damage mechanism by up to 300%. So this really gives us insights that we are really not having effective rehabilitation strategies. That's why our losses and damages are really egregious. Be it an earthquake followed by a flash flood, or be an earthquake followed by a riverine flood or anything else, and the vice versa is also true. So I'm going to show you about the bridges. This is about buildings, and then in this slide you can see about the bridges. For instance, we just try to pertain some of the vulnerability models and analysis of fragility functions for Nepali highway bridges after the 2017 flood, and then we also simulated some earthquake mechanisms to those bridges. Then what we found was, like, if you just consider a single natural hazard, then the damage mechanism or the probability of accidents, particular damage, will be least by 20% if you consider more than one natural hazard. So this really leads to severe consequences. For instance, your infrastructures will really lose functionality. You have severe economic consequences over the time period, and inoperability of such infrastructures have other consequences too. So in this figure, you can see that E indicates earthquake only, and E plus A indicates earthquake and flood. So if we have combination of both earthquake and flood, and it may be like followed by other stuff too. So if you have combination of several those, then surely the damage probability or probability of accidents will be really higher, much more higher for the same level of intensity, right? So if we just fix it, like we fix flood level to static level here, and then we analyze the earthquake performance, then what we observed was like more than 20% damage probability will be observed if we have more than one natural hazards, right? So if we have more than one natural hazards, then we need to really consider about different type of design strategies. Let's say we really go for a resilient type of resilient models or multi-hazard resilient models. And I'm really going to talk about resilient and resistant model later on in my slides. So the biggest message the slide is given is like, we cannot really deny the entry of the next natural hazards if something is already occurring there. So we need to be really concerned about this combination of natural hazards. So there might be a combination of independent natural hazards might be there, and other time there might be some cascading effects. So both of these packs and mechanisms will have very, very brutal consequences in our structures and infrastructure, especially I'm talking about Asia, right? So let's go to next slide. So in this slide, I'm really going to present some of the consequences of multiple natural hazards, because we are more focused on particular, that is the most devastating or most prominent natural hazard in particular region. For instance, in Nepal, we are just more than focused about earthquakes, but we are really forgetting about the flood force and then wind force and other mass movements, slope instability, and then bank cutting and erosion and other type of stuff. So the vulnerability that we are considering as of now is more focused to particular natural hazards. And then sometimes there might be ad hoc occurrence of other type of natural hazards that really makes us crazy, and then the damage may be something different than expected, right? In the first picture, you can see that was a really good design, I would say, but still that was swept away by the flood, because no one really considered about flood performance of such reinforced concrete buildings. The second picture, you can see that the wind was really crazy, and then that really affected the reinforced concrete building. And then the third picture, you can see there was a very well designed special moment resisting frame structure, but the slope instability issue was not really considered during this design, and then the mass movement was really crazy to make it collapse. And the fourth figure is the same, the story is the same, because they were just constructing the coastal region, and then after that there was the continuous bank cutting, and then it got deployed to some other region. So in the last picture, you can see that we are just focused about particular stuff, and then we do not consider other forces, so that particularly wind might be there, fire might be there, and other type of forces might be there. So that can really create a troublesome situation, and then all the buildings and structures or infrastructures will lose their functionality. So in this case, like the message of the slide would be like, we just consider the combination of forces. Like we first study the particular impending situation of different forces in particular region, and then we just plan for design and other stuff. So let's go to our next slide. Here I'm going to tell you that particularly it is a very boon, or it is a very, very much benefit that if we have just one type of hazard. But if we have more than one, then we are always in trouble. You can see that particular multiple independent natural hazards may occur. And I was telling that Asia is really poor in rehabilitating structures and infrastructures immediately after some particular natural hazard. So if we cannot really fix it on time, then next natural hazard will occur, and then the sequence may occur there too. So sometimes that happens, but another time, if there is a cascading effect, for instance, earthquake trigger landslides, earthquake trigger fire, earthquake trigger floods, or flood trigger landslides, or in several other combinations might be there. So that in case of cascading hazards, no one really knows about it, and then what happens, right? Because we can easily figure out the combination of forces, but it is very difficult to have cascading effect-based analysis. So scientists across the world they're really focusing on developing some cascading-based model. So here we have done some work. Like we would like to focus on region by region in the least possible region. For instance, if you see the picture in the middle, then you can see the multi-hazard local level zonation. So if you have some sort of zonation stuff, then you can really go for a particular region, and then you can select some different building types. So there might be several combinations of different natural hazards, and then in this case, like you can really take account. For instance, if some particular regions are prominent of, I mean, they're really likely to get flooding in particular season, and then if that is really close to the seismic region, or it is under high seismic region, then you can really combine flood force and earthquake force at a time, and then better deploy different type of design a prototype or a different type of building form or different type of infrastructure system. For instance, in some regions there might be quite rocky area, then you do not need to really worry about any other stuff, then you can just go for earthquake. So it is up to you whether to choose natural hazards in a combination or solely. So if you are really forgetting other hazards, then there might be severe consequences from other hazards. For instance, if you take the last figure, then you can see the multi-hazard zonation of Kathmandu Valley. So most of the urban fringes, they are really unscathed, but the central urban areas and then other particular city stuff is really having very high level of multi-hazard combination. But in particular, we are just focusing on the earthquake resistance performance, and then we are just going for spatial moment resisting frames. But sometimes in ad hoc situations, we get urban flaws that are making us crazy, and then the functionality is really lost during that time. So we need to focus about the combination of natural hazards in particular regions. So in Asia, if we talk about, we can really read in news outlets and other stuff that we relegate a lot of natural hazards, and then they come in combination. So for me, that in Asia, rather than talking about single natural hazards, it's better to talk about multiple natural hazards, making combination and then deploying the same rehabilitation or recovery effects or programs. So the time is really high for us then, whether we need to choose between resistance and resilience. It is very clear. So if you just want to withstand particular force, then we go for resistance, because a lot of people in seismic regions, they are talking about earthquake resistant buildings, but they really forget about resilience, because resilience has some sort of recovery function. So resistance does not have some particular planning for recovery. So if you do not talk about recovery, then you are literally lost, because you just try to get balance with particular force or multiple natural forces. But you forget that it needs to bounce back to normality after a period of time. And then if it does not really bounce back, then functionality is lost. So we are focused as a civil engineer, we are focused on functionality. So if functionality is not restored on time, then there is no use of such a structure. So we need to better focus on resilience rather than resistance. So there is a hoax like resistant is that does everything, but that really does not does everything. So resilience is the particular stuff that we need to really focus on. So to have resilience, I interchangeably use resilience and sustainability. So we can use the same approach of recycle, reuse, recover, and reuse. So you are more familiar, I guess, and then we cannot really talk about every aspect of resilience here in this very short stuff. So the message I really want to give to you is like resilience is the future, and then we need to focus on more recovery-based stuff rather than resistant or just withstanding things, right? So products. So what we're gonna really take, what are the takeaways of today's talk? It's like resilience begins at home. Means it should be started with very little, smallest possible infrastructure or structure, and then we can really generalize it for large infrastructure. So multi-hazard. So there is a very, very, very big misconception. Like there is a very big misconception. They say that if you talk about multi-hazard resilience, then it is expensive, but that is not really expensive. If you just talk about, or if you just focus, or if you just perform some studies related to life cycle analysis, then you can easily understand that multi-hazard resilience is not really that expensive, because in resilience, we talk about the recovery stuff, and that really gives you some better idea regarding why you need to do operation and maintenance every time in your resistant models, and why you can really skip those stuff in your resilience model. So at the end of the day, if you think about the functionality period, then it becomes neck to neck. So you really should not worry about resistance. You should not really worry about the expensive nature of resilience. So you just go for it, and then it really assures life safety, or I would say that whatever performance level you are designing for. So unforgetting impending hazards, remember resilience. It is very true that if you do not forget all the impending really natural hazards, then if you are considering all the natural hazards in particular region, then it really remembers resilience so that you are much prepared and you are more focused on recovery. But if you just forget one, then the next, the forgotten one will have severe consequences to your structures and infrastructure. So sustainability and resilience, I use them, as I said, I use them interchangeably, but there are several school of thoughts that divide the line of thoughts between sustainability and resilience. So we can use the same sustainability principle in resilient design. We can use the same sustainability principles in resilient based assessment and then rehabilitation strategies. So everything can be really collated with resilience at the end. So these are our some of the works that we are doing currently, or we just finished. So the first picture is a multi-hazard resilient vernacular stone masonry construction that will be started on Sunday. So Sunday we're going to start with this model, and then we will just try to figure it out what happens with the occupants and what happens with the natural forces over the period of time. So we have considered hailstorm and earthquake as the particularly two natural hazards that are considered in this design, and then we just try to make it resilient in these two types of natural hazards. In the second picture, you can see a combination of several types of structures. The first one is waterland dub, the next one is a silly structure, and then you can see some of a raised plinth over there. And the third one at the edge, you can see RC building with the raised plinth. So the second one is in particular very interesting, designed by some Taiwanese architects. So that's really considered flood and earthquake forces to have better performance during floods and earthquakes. So we are trying to assimilate the knowledge and then experience from different type of stuff. So these are my references I prepared, I consulted during my preparation. And at the end, the message is the future is Asia, and then multi-hazard resilient Asia is possible. Thank you so much.
Well, thank you so much for your wonderful presentation on Beyond the Threshold of Multi-Hazard Resilience Lies. In fact, the topic is really interesting, and the context on the cascading natural hazards, it is indeed the topic which we are we need to look for, and we should be prepared for the multi-hazard approach. And also the insights on resilience and resistance was also quite interesting. And also we would like to wish you all the very best for your upcoming assignment. And so he's been an inspiration to all of the young researchers. And ladies and gentlemen, so without much further delay, I would now like to request you to we'll be welcoming our third speaker for today. So we have, let me share my screen. So we have engineer Amrita Gautam, who is a civil engineer pursuing her doctoral research in Germany with a special focus in hydroinformatics, water supply engineering and management. Having work experiences from various UN organizations and research projects in Nepal, Germany, Mozambique, Brazil, Canada, and USA. As a young water professional, Amrita has been involved in World Youth Parliament for Water, International Water Association, Soroptimist International, Youth for the Rhine, and Girls in Tech Nepal. She was awarded with Women with Vision 2018 and received Soroptimist International of Europe Scholarship Award in 2019 and got selected as an ambassador of Rising Smart Water Professionals in 2021. Our ongoing doctoral research is about the water supply and quality monitoring via emerging technologies, and the case study area is from the Pokhara metropolitan city in Nepal. She has founded a research initiative, Drink Pani, which refers to drinking water information kit and believes in shaping digital water future. So, Ms. Amrita, the floor is all yours.
Am I audible?
Yes, yes, please.
Yeah, thanks to Razi, Purnimaji, Tirtha sir, and my fellow speakers for the warm welcome, information, and nice introduction. Kind gratitude to the entire team of the Asian Civil Engineering Coordinating Council, Future Leaders Committee, Nepal Engineers Association, and all participants for this wonderful opportunity and support. I'm going to present today the context of my ongoing doctoral research, as Suraj ji said, about the development of suitable model and empowering citizens through data-driven engagements with youth at the central role and ICTs as the main tool to enhance drinking water security. The case study area is Pokhara Metropolitan City, Nepal. Next slide. Suraj ji, next slide. Yeah, so we all know that today it is a great coincidence that we have got a World Youth Parliament, we have got a World Environment Day, and the theme for 2021 is Reimagine, Recreate, Restore, and we have also UN decade on the topic ecosystem restoration. And since I do not want to go longer on this discussion, we all are aware on this topic, but I just want to indicate some of the key aspects here. Some of the things are really crucial when we are given some tasks as professionals and some persons who are trying to bring some change, and these are the things that I'm also trying to introduce from my research work, and I can see my other fellow speakers have been doing the same, and all other participants here must have been doing the same. So the key focus should always be there to raise awareness, co-create initiatives that should always start from early age. I really focus on that part and doing research right now in this topic, and suitable and smart technologies, models, and effective implementation, empowering citizens through the data-driven engagements like that I will also explain more in later slides, and using our engineering skills here. We all, like most of us, I think we are civil engineers, and that's what we are talking right now. So we need to keep learning and need to utilize our engineering skills and expertise for a social cause with institutional governance, so that we can actually do something with responsibility and honesty. We need to be honest to ourselves for the effective impact that we can bring to our society. And all the very important thing that we all know, every decision should be based on evidence. So evidence-informed decision making is the must. Next slide. And the main context here, when I'm talking about the safe drinking water and basic sanitation facilities are essential for human civilization. We all know that. But we also know that not everyone in the world is able to receive these facilities. According to Joint Monitoring Program, JMP 2017, only about 5.2 billion people use safely drinking water services in 2015, here you can see, and the developing countries like Nepal is in between 26 to 50% in proportion of population using safely managed drinking water services in the same year. In addition, the same report also indicates around 2.4 billion are still using unimproved sanitation facilities, especially in developing countries, resulting the linkage of more than 80% of illness to these issues. Next slide. And we also know how important and crucial the relation between water and public health is. In this graph in left-hand side, it shows the proportion of population using improved source and the case of E. coli detection. It explains about 91% of population has got access to improved source, and more than 70% of population has got access to the improved source, but with E. coli detection. This indicates the need of proper monitoring mechanism in its place. The second graph shows about 2.2 million people die from diarrhea each year, where about 90% of those deaths are of children, mostly from developing countries. We are aware of this fact. And in the context of Nepal, about 44,000 children die every year under the age of 5 with a lack of safe drinking water and poor sanitation situation. That's the case. And so these are the things so crucial, like how this context, water and public health, is like directly linked up, and we have to be very cautious. So the next slide is about the questions and the work. Next slide. So here you can see, out of all these issues mentioned here, several questions came ahead. And the important question for me and my research team has been, do we have regulation in drinking water quality monitoring mechanism? And this directs to other set of questions like, are we able to involve the youth at the center of monitoring initiatives? Does it really support? And what is the suitable design for the involvement? How about data accuracy, reliability, and the sustainability model, like so that it can have an impact not just for one time, but the continuous process on like till the water resources is there, until our human existence is there. And how about utilizing the knowledge of local women in this process? What about important, thank you, Surezi. What about important factors for long-term support and about climate resilience and adaptation, including the emergency response and the crisis management? So, and you can also see the case study right here, Pokhara Metropolitan City. And I think most of us, you are quite aware where this Pokhara Metropolitan City lies, especially the people of, like for sure, the people of Nepal and all the colleagues here, they might be familiar in this context as well. It is inside Kaski district in Gandaki province. And here you can just see this, like general information about, like we all, like most of us, we know that the Pokhara Metropolitan City is the biggest metropolitan city right now in Nepal. The rapid urbanization has make it a complex situation, as it is one of the most attractive touristic places of our country. So it stresses to natural resources, thus it comes to the water resources as well. So high demand, not sufficient supply in terms of drinking water supply, including adequate quality. So the context of rapid urbanization is clearly visible in the second figure as well, like land cover from 1988 to 2016. So next slide. Thus, Drink Pani is the research-based initiative, and it intends to bridge the gap between water utilities and communities in information flow on water supply and quality, with youth as key actors and ICTs as the main tool to navigate the path to reach policymakers for evidence-informed decision making. That's where I have been putting stress. So therefore, leveraging the capacity of youth in smart water from local grassroots initiatives to the global impact is the must. And here we can also see the outlook of methodological approach. Due to the time limitation today, I'm not able to describe it in detail, but the important part is the youth-led participator sensing model is to support in surveillance monitoring, where water utilities lack the sufficient and active manpower for regular monitoring. We are quite aware on this context, especially in developing countries, though given with tools and equipment to test and share water supply, sanitation, quality monitoring data for effective communication flow, that we know what is not happening. So next slide. So here comes about the topic now, digital tools, fieldwork, and initial outcomes. Here you can see we've launched our own app and website called Drink Pani. It reflects to the continuous iteration process more than 1.5 years now, like almost 2 years, with users and advisors to come to this point. We know water works in the first line of defense for a healthy living, and Drink Pani believes in shaping digital water future. In this initiative, next slide, youth are the key actors as young water volunteers assigned officially in water clubs with intensive training, tools for water sampling, tests, data collection, reporting, and sharing under youth-led participator sensing YPS model in progress. For the pilot case study, 2 schools named Janapriya Higher Secondary School and Gurukul Vidyashram were chosen to cover the 2 selected water supply scheme of Pokhara Metropolitan City. Next slide, the graphic here of the initial results, so the variation in water quality index and the temporal variation of parameters, pH, electric conductivity, free residual chlorine, total hardness, and echoline, Siswakhudi area of Leknath water supply scheme, Pokhara. Since we do not have much time left, so I'm just trying to rush. So if you have any question, we can also discuss afterwards, or even we can talk in email. Next slide. So now, with the regular workshops, seminars, and training sessions, including direct consultations with water utilities, other stakeholders, and advisors, young water volunteers, we have given the official name, Young Water Volunteers, tend to support in climate resilient water safety plan for the respective water supply schemes. But this pandemic has posed a huge challenge in direct field work, as all of us, we are suffering globally in one or other way. Nevertheless, we are utilizing the opportunity of digitization in collecting information from local story submission and empowering the local communities through young water volunteers with regular workshops and boot camps. And we are also trying to collect data in different other formats, and we've been making our strategic planning like for the regular data collection process directly from the field. If we are determined and positive, we can get way forward. We all know that in every challenge we face, that's where the opportunity lies, and that's where Drinkpani is working for and looking forward. If next slide. And these are some of the collaborators, partners, advisors that we've been working on. And I just want to convey my note of thanks and actual acknowledgements. And like I have already said, for the organizers today and all the partners, I again extend my thanks and gratitude. And in the final slide, I have also put some of the references. And next slide. Yeah, as I've said, due to the time limitation, I could not explain everything in detail as other colleagues have done the same. So if you have any question, you can also write in chat or you can also write in email. Thank you so much.
Thank you so much, Amrita Gautamji, for the wonderful presentation on youth-led participatory sensing model to enhance drinking water security, a case study of Pokhara Metropolitan City. And it was really interesting to hear from your wonderful Drinkpani initiative, especially engaging youths and like this participatory initiative. So I, along with our organizing team, would like to wish you all the very best. And with this, we have completed our 3 presentations for today. And then we would like to now open the Q&A session. So one more thing to add upon, we have shared the link for the feedback survey form. So with this form, we'll be able to prescribe what may be the potential topic for the next webinar. You can suggest us using that link and also share your views. And also you'll be eligible to get the participation certificate after you fill up this form. So now moving on to the Q&A session, we have some queries in the chat box. And of course, I can see Asi smiling over there. So maybe I'll just start with Asi. Asi, maybe you could keep it in through your voice. Yes, please.
Okay, hello. Maybe I will keep it quite quick. I was very, very excited with all of the presentations today. Hello, my name is Asi. I'm from Indonesia. Thank you for all 3 presenters, but perhaps I would like to have a question, especially to Mr. Dipendra, because our concern is quite similar. I'm also doing somewhat similar things in terms of multi-hazard analysis here in Indonesia. And I was actually really curious about the fragility curve that you were showing earlier, where you combined, you compared the differences between the fragility analysis by using just earthquake and combining it with flooding. And I would like to know how precisely you were able to do that, and what the fragility curve actually means, because obviously it was very fast before. And for the zoning that you also showed, I think that simply shows the layers of the different possibilities of hazard, if I'm not mistaken. Anyway, so these are some of my questions. I hope it was quite clear. And I returned back to you, Suraj. Thank you.
Thank you so much, Asi. So over to you, Dipendra sir.
Hey, thank you so much for your question. Maybe yes, fragility is the curve. I would say that's a function that indicates the probability of accidents or particular damage, right? Damage, I'm repeating it. Damage in particular or in designated intensity measure, be it peak ground acceleration, be it the depth of inundation, be it the wind velocity or anything, right? So our experience says that particularly it's very difficult to model the hydrodynamic behavior of water, because during flooding, it is not pretty sure that the flooding is static. So it may have some velocity, and that really exaggerates the damage, means aggravates the damage. So that might affect the fragility function. But what I'm pretty sure is our earthquake modeling is quite, I mean, that's more precise, right? So what we did in that case is like we just considered static water level, means just inundated with no velocity. So the next avenue is like considering the hydrodynamic effects of water and then combining it with the earthquake analysis. So that gives you more precise results. So it may be, but it depends on what type of terrain you are considering. Maybe if it is a flat terrain, then it is sometimes more or less a static consideration. It's more representative, or I would say that just representative enough. Or if it is really a flat terrain, not flat terrain, like steep terrain, then surely the hydrodynamic behavior that plays a great role. Your next question was like local level multi-hazard zonation. That was not just overlaying. There was consideration of historical natural hazards, consideration of losses due to those hazards, and providing weightage, and then combining them and developing a qualitative measure and index system. And then after finally we got that. So it was like a rigorous analysis rather than just layover. Thank you.
Okay, so just to confirm a little bit, so the axis of the fragility curve when you made it into the PGA, so the flooding there actually is like the hydrodynamic flooding
No,
that
hydrostatic flooding.
Hydrostatic flooding that might happen with the same PGA. So the meaning is still the same as an earthquake fragility curve.
To clarify you, let's imagine a situation like there is already inundation, some sort of inundation, and then earthquake happens right there. So the fragility functions that represent that.
Okay, thank you very much. Sorry for the question.
Oh, it's cool, thank you.
Thank you so much, Dipendra sir, for your lovely insights. So I have one more question here for Chhatra sir. Sir, I had studied on some of the world hydropower paper, but in the same height of water fall or water head, the capacity of production is very low in Nepal compared to the other country. So why is this, and doesn't it affect on our economy? Why the capacity can't be same? So could you just have some insights onto this?
Okay, thank you for a very important question, and it's more related to economy and to the society. In fact, thank you, Puranjan, for very important question. So for the hydropower capacity, we need to have height as well as water quantity. So it depends on water quantity as well. With the same amount of water and we have the same height, then it's the same capacity that you will get, whether you are in Nepal or whether you are in Norway or anywhere else. It's the same. So I don't think the capacity will be different, but the production so far in Nepal is very less than what we can generate the electricity from our resources. So that's another important question that you also asked. So compared to the other countries, our hydropower history is quite old, but we couldn't proceed, we couldn't continue our production due to our political situations or other reasons. So nowadays, it's the production is being increased, and the public sector also came into the industry, and they are investing money, and also the country is more into it nowadays. So I think in future it will get accelerated, the production will get accelerated, and of course it affects on our economy very. It will have huge impact on the economy, because the electricity is the basic infrastructure, just like road and just like the health sector and all these. We need to have electricity to build anything. For example, to build the industries and to for our daily life. So in future, I think my hope is we'll have more capacity of electricity, and we'll have quality electricity, because nowadays we are improving our quality as well, and we can export our electricity to other countries, neighbors, and we can import from them and as per requirement. So I think in future we'll do better. That's what we are working. I think that's
Thank you so much, Sadar sir. Yes, indeed, we do have a lot of potential, and we look forward to working. And definitely, we are hoping for our best, as the infrastructures has been it's on a good note that we are developing our infrastructure quite rapidly in these days. So we have a number of queries. But the we have some time constraints as well, so maybe we won't be able to take all the questions. So maybe I would like to request Mr. Sailendra Ram, the ACCC Deputy Secretary General and ACIC FLF co-chair, to please have some few words. Sailendra sir.
Okay, thank you very much, Suraj. I'll be very quick. Thank you very much to my colleague, Professor from Nepal Engineering Association, for the nice opening remarks. And thanks very much to the hosts, Purnima and Gautam, and to the three speakers. I think it was a very good interaction. It's great to see what Gautam and Purnima and the colleagues who may have assisted them. And we got close to 778 registrations today, and it's an excellent, it's probably a benchmark set now. So with all the colleagues, my colleague from Nepal Engineering Association, and on behalf of ACIC, thank you very much for this evening's presentations. And then, by the way, the presentations were really good quality. The actual PowerPoints were really good, and the conversations were very good. Thank you very much.
Thank you so much, Sailendra sir. So I would like to remind you once again that we have shared the feedback survey link on our chat box. So please feel free to write here. And then due to the time limitations, we are able to take this much questions for today. So maybe if you have any further queries, you can please reach out to our email. We'll be sharing this presentation, this recording of this session in our YouTube channel, and we'll also be sharing the email address of our speaker. So in case if you have any other queries, you could please contact them, and we'll be happy to address them. And for now, we are almost done. So we'd like, on the behalf of our organizing team, I'd like to thank all of our eminent speakers for the wonderful presentation. The session was really interesting, and it really we were able to witness some of the excellent works which you have been doing for so long, and we'll be happy to learn from them and also execute them. So for now, I would like to now request the chair of our ACIC FLC, Ms. Prasanti Asi, to finally conclude this and in this program for today. Thank you.
Okay, thank you very much, Suraj, for giving me the opportunity to talk again. So actually, I was too engaged in the conversation that I was like, oh, I have to prepare something to say. But anyway, so on behalf of the AACCC Future Leaders Committee, I would like to extend again a warm thank you to everyone from NEA for organizing this whole webinar. I think all of the topics were amazing because that's why there are almost now 250 joining us today, even 800 registered. And we started by learning from Dr. Chatra about large underground opening for hydropower plants. And then Dr. Dipendra also enlightened us about the multi-hazard perspective of disaster mitigation. And lastly, also the presentation by Mrs. Amrita emphasized the importance of drinking water security, which we also all believe to be very, very important. So all of the knowledge shared today by our fellow engineers from Nepal is in accordance with the mission that we have in ACECC, where we believe that we want to advance the acquisition and transfer of civil engineering knowledge through these types of conversations between countries. And I really think that today marked like the reality that it's actually possible to share knowledge. I'm already intrigued by all of the things that we learned today. And maybe before we end, I would like to share the dates for some of the events that we are going to have after this. So actually, we will host another international webinar in July by the Philippines, PICE, and then another one in August by Pakistan, IEP. Lastly, in September, we will have an ECM hosted by the American Society of Civil Engineers. And in October, we have one hosted by India or ICE. And if you are are interested in joining all of this, please don't forget to fill in our form. We have already distributed the form through our chats, so that your email will be in our database, so that we can actually send you the invites once it's there. And then lastly, also another very important information is that we have the CCAR happening next year in 2021. So if you're interested in actually submitting your papers, the abstract due date had been pushed by 2 months, so you can still send until the end of July. So if you want to learn more about this, you can go directly to ccar9.com. And yeah, thank you very much again for all of the kind presentation and an amazing organization by NEA for this webinar today. Back to you, Suraj.
Thank you. So we'd like to take one photograph and then we'll end this